find the partial fraction decomposition of x over this cubic x cubed minus x squared minus 2x plus 2. Now, first thing we have to do is factor the denominator. In this case, we have to use our polynomial factoring methods. One way, I'm not going into too much detail, but one way is to plug in numbers that are factors of the constant, for example, 1, -1, 2, -2, into this entire expression and see if it's equal to 0. And so if just by trial and error, you can find that if you plug in 1 into x, it'll be equal to 0. And so that is a factor. X minus 1 will be a factor. You can use synthetic division to divide, and so you'll see this factors into x minus 1 times x squared minus 2. You can see we have a linear factor and a quadratic factor. And so our linear factor will get just a constant a, and our quadratic factor x squared minus 2 will get a linear expression in the numerator bx plus c. And so we have to solve for these three constants, a, b, and c. To do that, we're going to multiply both sides of this equation by the entire denominator on the left. And so we get just x on the left. For this fraction, the x minus 1 will cancel out, but we still have x squared minus 2. And for this expression, the x squared minus 2 will cancel out, but we still have x minus 1. And so we have to expand this. On the left here, we distribute the a to get ax squared minus 2a. On the right here, we use the FOIL technique to multiply these two binomials. This is what we get. And what we're going to do is we're going to equate coefficients by collecting like terms, then factoring out the variables. So for the quadratic part, the x squared part, we have a plus b x squared, factored out the x squared. For the linear part, we have negative bx plus cx, so we factor out the x and we get negative b plus c. And for the constants, we have negative 2a minus c. And now what we're going to do is we're going to equate coefficients. And so for the right side to be equal to the left side, notice there's no x squared term on the left, and so the coefficient for x squared on the right must be equal to 0. In other words, a plus b has to be equal to 0. For the x term, we can see we have a coefficient of 1 on the left, and so negative b plus c has to be equal to 1. And finally, for the constants, you can see there's no constants on the left, and so a negative 2a minus c has to be equal to 0. So now we have three equations, a system of equations to work with. We have to solve for all three variables. I chose to use substitution. What I did was I solved for b and c in terms of a, for using equations 1 and 3, and then I plugged that in for b and c in the second equation, and I'll get just an equation just in terms of a, which I can solve for a. And so in the first equation, b equals negative a, and c equals negative 2a. And so now I can plug this into our second equation, negative a, negative 2a equals 1. I get negative a equals 1, and so a equals negative 1. And we can plug that a value into these two, and you'll see that b equals positive 1 and c equals positive 2. So now we have our three constants. We can plug them in back into our original. A is negative 1, so we have negative 1 over x minus 1. B is 1 and c is 2, so we have x plus 2. And so this is our final answer.